Here's another example of using the segment addition postulate. This one's a little more complicated because we have an algebraic expression, so we have a variable in here. And so we want to find the measure of segment PR, so we want to find the entire length. And so just to write this out, we can say using our segment addition, we know that PQ, the measure of PQ plus QR equals PR. So we know that PQ, the measure of PQ plus the measure of QR is equal to PR. And now again we can, and this is our segment addition postulate. Okay. I'm going to try to write these reasonings out because later on when we get to proofs, okay, in geometry we always want to justify what we're doing here. So this is our postulate. We accept this is true. So now I can substitute in these measures, okay, for each of those. So PQ is 10. QR is 2x plus 1. And PR is this entire length, we're told is 5x plus 2. Okay, and this is just, our justification is substitution. And so now we have a linear equation here that we can solve. We have an equation in one variable. So what we need to do is get all of our x terms on one side and all of our constants on the other. There's no necessarily one way to do this, so I'm going to go ahead and combine the 10 and the 1. So 11 plus 2x equals 5x plus 2. And that's just a matter of combining like terms, and now I'm going to subtract 2x from both sides. And I can also then, I'm going to subtract 2 from both sides. Okay. That's going to leave me with 9. 11 minus 2 is 9, and 2x minus 2x is just 0. 5x minus 2x is 3x, and 2 minus 2 is just 0, so I get 9 equals 3x. I can divide both sides by 3, and I can get that x is equal to 3. Now, we weren't asked to find what x is, right? So we're not finished there. We're asked to find what PR is. So since PR is equal to 5x plus 2, I'm going to plug in 3 for my x, and that's going to be 5 times 3 is 15 plus 2 is 17. So the length of PR is 17. Now, just some notation comments here. We talk about geometric objects being congruent, right? Shapes are congruent, meaning that they have the same shape and size, and the congruent symbol is this equal sign, the little squiggly line on top. That means congruent. If two segments are congruent, we also say they have the same measure, okay? But we talk about geometric objects like shapes and segments being congruent, but we talk about measures being equal because measures represent real numbers. So numbers are equal to each other, segments are congruent. So it is correct to talk about segments being congruent. So I can say segment AB is congruent to segment CD. But I can talk about their measures being equal. So if this is true, if these segments are congruent, then I can say the measure of AB is equal to the measure of CD. So that's just a notation convention that we follow. So keep that in mind so you know the difference between talking about a segment, which we can say is congruent to something, or a measure, which we can say is equal to something.